Welcome to this explainer. I am so excited to have you here today because we're diving into a truly fascinating shift in the world of digital entertainment. We're going to take this somewhat abstract, high-level idea of true digital ownership, and we're bringing it right down into a really clever technical mystery. And get this, we're doing it by looking at one of the most classic, nostalgic games of all time, Hangman. Seriously, think about it. How do you play a game based entirely on secrets on a network where literally everyone can see everything? It's just a fantastic puzzle, and I absolutely can't wait to unpack it with you. So, let's just dive right in.
Okay, here's our roadmap for today's explainer. We're starting with the macro view, the blockchain gaming shift, followed by why developers are building on EOS. Then we'll hit the core puzzle, the transparent game dilemma, before looking at Hangman under the hood and revealing the cryptographic secret. Finally, we'll zoom back out to look at the future of play.
All right, kicking things off with Section 1. The blockchain gaming shift. We're moving from rented items to true asset ownership. And, let me tell you, the very foundation of how we interact with digital games is undergoing a massive transformation right now.
Think about it like this. Traditional gaming, it's essentially a black box. You spend hours, maybe years, acquiring gear, leveling up characters, hoarding items, but you don't actually own any of it. You're just licensing those items from the publisher, who keeps everything locked up on their centralized servers. If they decide to pull the plug tomorrow, poof, your hard work just vanishes. On the flip side, blockchain gaming acts way more like a glass box. The game logic itself lives directly on chain. You hold the actual cryptographic keys to your hard-earned assets, usually as NFTs or tokens. Basically, as long as the blockchain network exists, your game and all your stuff exists right alongside it.
Now, to truly grasp how this shift works, we got to understand the engine powering the whole thing, the smart contract. Think of a smart contract as this completely unchangeable, automated referee. It's self-executing code that enforces the rules of the game immutably. That means the rules absolutely cannot be altered on a whim. It completely eliminates the need to trust some central game publisher because the code itself makes sure that no one, literally not even the developers themselves, can cheat or secretly tweak drop rates behind your back.
Moving right along to Section 2, why build on EOS? The infrastructure for seamless gameplay. Because honestly, if a game is slow or super expensive to play, well, nobody's going to play it.
So, why are developers flocking to the EOS network? Basically, to solve those historical bottlenecks that used to plague blockchain games. First off, zero gas fees. Players don't pay per action fees, which makes microtransactions totally practical. Second, you get this incredibly responsive gameplay with half-second confirmation times. Honestly, you probably won't even realize you're playing on a blockchain. Add in a highly scalable architecture and modern developer tools like the WorfKit SDK, and you've got a playground that feels like traditional web development but packed with Web3 superpowers. Just consider this incredible metric for a second. Over 3,000 transactions per second. That is massive. It proves that the network actually has the sheer muscle required to support these huge real-time multiplayer ecosystems without just grinding to a complete halt. But wait, speed and scale usually come at a massive cost, right? Well, not here. It achieves all of this performance while using roughly 0.000001 kilowatt hours per transaction. That makes the whole ecosystem incredibly energy efficient and environmentally sustainable, which pretty much shatters that old myth that all blockchains are these massive energy hogs. All right, on to Section 3, the transparent game dilemma, or hiding a secret in a glass box. This is where we face a really fascinating pivot that challenges everything we just talked about regarding blockchain transparency. Because here's the ultimate brain teaser for you. If every single piece of data on a blockchain is public for everyone to see, if anyone can audit the ledger at any time, how on earth do you play a game like Hangman, right? The entire premise of Hangman relies on the player not knowing the word. If you just slap the word onto a public blockchain, any player could just peek at the code and cheat. It completely ruins the game.
And to make things even more complex, the developers behind this explainer's example decided to use Netflix movie titles for their version of Hangman. So now we have this incredible challenge. How do you bulk upload roughly 8,800 Netflix movie titles onto a fully public network without spoiling the answers? How exactly do we hide this massive catalog of secrets right in the middle of our glass box?
Well, let's jump to Section 4, Hangman under the hood. We're going to structure a decentralized game and see exactly how they built this on the Jungle 4 testnet.
Okay,
So the magic really starts to take shape in how the data is organized here in the titles table. You got a basic primary key and a pattern field. That pattern field just shows the player the title mask, the blank lines and dashes that tell you the word length, giving you a tiny hint of what to guess. But sitting right there in the middle is this mysterious hash field. Keep that hash in the back of your mind because it is literally the key to this whole puzzle.
Next up, we need to track the active state of the game. So this games table pairs the specific player's account name with the title ID from that previous data. It manages all the basic mechanics, counting down your remaining attempts from 5 to 0, updating your status from active to 1 or lost, and even logging your last guess for total transparency on the chain. And actually, player sessions here are handled super smoothly right on the front end using standard Web3 wallets. So the game flow itself is elegantly simple, broken down into 3 main actions. Action 1, Start Game. This creates a new game and randomly selects a title. Action 2, Guess Word. This is where the actual gameplay happens. But catch this, instead of guessing letter by letter like traditional Hangman, the player submits a full title guess on-chain. And finally, Action 3, Endgame, which basically just allows a player to abandon their current game if they get totally stuck. And now, Section 5, the cryptographic secret, how hashes secure the gameplay. We have finally arrived at the aha moment of our explainer. Let's reveal exactly how this contract keeps that Netflix title a total secret from prying eyes.
The central innovation here is this. The actual movie names are never written to the blockchain. Only their cryptographic fingerprints are. Remember that hash field we looked at a minute ago? That's the fingerprint. The blockchain doesn't actually know the movie name. It only knows what the movie name looks like after it's been mathematically scrambled by an advanced cryptographic algorithm, and you can't reverse engineer a hash to find the original word, which means staring at the blockchain code gives you 0 advantage. It's brilliant.
So how does this translate to actual gameplay? Well, when you make a guess, the smart contract immediately executes 3 exact steps. First, it converts whatever text you inputted to lowercase. Second, it computes the SHA-256 hash of your guess right there on the fly. And third, it compares that brand new hash it just created against the permanent fingerprint hash stored in the titles table. If the 2 hashes match perfectly, boom, you win. If not, you lose an attempt. It is a flawless way to preserve a secret while still allowing for completely trustless automated verification. Now, I do have to point out, just to be totally fair, that this is currently a testnet build, and there are some limitations to be aware of. For instance, pattern vulnerabilities. A clever player could theoretically grab the blank letter pattern from the blockchain and write a script to cross-reference it against a public database of Netflix movies to narrow down the answer. Sneaky, right? Also, the title selection currently relies on time-based pseudo-randomness. If you were going to build this for a production environment with real money at stake, you definitely need to integrate verifiable random function, or VRF oracles to ensure absolute, ungameable, true randomness.
Which brings us to Section 6, the future of play, interoperability and decentralized ecosystems. Now that we understand how you can build a secure, fast, and trustless game on the blockchain, we really need to look at the broader implications of what this Hangman experiment represents for the whole gaming industry.
By combining 0 gas fees, cryptographic security, and true asset permanence, developers are laying the groundwork for something genuinely spectacular. We're looking at a future absolutely filled with integrated token economies where you can stake and trade your assets. There's no central point of failure, giving your favorite games true permanence. And thanks to modern integrations, the user experience is finally becoming seamless. All of this points directly to the holy grail of gaming, true asset interoperability, where your time, your effort, and your skill actually translate into real, lasting value.
So, I want to leave you with this provocative thought. As smart contracts make digital assets mathematically truly yours, we are approaching a wild new frontier. Think about it. What happens when the magical sword, or even just the high score you won in one game universe, can be sold, traded, or actually wielded in an entirely different game universe? The boundaries between video games are about to blur entirely. Thank you so much for joining me to explore the trustless game. Keep asking questions and keep learning.